Okay, in this lecture we're going to talk about how to do calculus in polar coordinates, and this will be a shorter lecture. Okay, this isn't going to be terribly lengthy. Okay, first thing I want to do is show you how to find dy dx in polar coordinates. It's very similar to parametric coordinates. We find dy dx by doing dy d theta divided by dx d theta. Now, in order for that to make sense, you need to remember something, okay? You need to remember, first of all, that we have the equations x equals r cosine theta and y equals r sine theta. But you also have to remember something else. You have to remember that when an equation is written in polar form, you're going to have an equation like, let me just write this one down, something like r equals 1 plus cosine theta. In other words, you need to remember that theta is usually your independent variable and r is your dependent variable. So r is a function of theta. So it's actually, when I say r equals 1 plus cosine theta, I mean, I could actually, if I wanted to, write r of theta. So you need to remember that that's true with these r's up here. They are actually functions of theta. It would be, in this particular case, it would be 1 plus cosine theta in both of those. Okay, now why that's important is because when you're going to do dx d theta or dy d theta, you have r as a function of theta, and that's multiplied times cosine theta or sine theta. So you have to use the product rule when you do that derivative, okay? So here's what we're going to do. Instead of just writing x equals r cosine theta, I'm going to write x equals r of theta times cosine theta. And for y, I'm going to write r of theta times sine theta. Okay, so then when we do dy d theta, let's write that down here. dy d theta, what's that going to be? Got to use the product rule. So that's going to be r prime of theta times sine of theta plus r of theta times cosine theta. Okay, that's going to be on the top up here. And then on the bottom, what do we have? dx d theta. That's going to be r prime theta times cosine theta plus r theta times negative sine theta. Let's put that negative out front here. Make that plus a minus. So that's going to be on the bottom up here. R prime theta cosine theta minus r theta sine theta. Okay, now I do not actually suggest that you memorize this. I suggest that you remember this. Okay? So let me show you how I would do a problem of this type. Let's erase this gray work here. Okay, we're going to do an example. Okay, let's do this question. Find the tangent and normal lines to the circle given by r equals 2 cosine theta at the point where theta equals pi over 6. So where's that point going to be? It's going to be right about there, correct? So let's find the coordinates of that point. Now, we want to find the tangent line. Let's draw that in red here. The tangent line. Lines are straight, they're not round. So rectangular coordinates are better for lines than polar coordinates are. So I would like to find this point in rectangular coordinates. And that's easy to do. Okay, let's just remember that x equals r cosine theta. But for this particular circle, r is 2 cosine theta. So that means that x is going to be 2 cosine theta times cosine theta. Okay, because this is r right here. So x equals 2 cosine squared theta. Let's find y. Y equals r sine theta. So that's going to be 2 cosine theta sine theta. Which happens to equal sine of 2 theta. Because cosine theta times sine theta is half sine 2 theta. That's a trig identity. Okay? So let's go ahead and leave that like that. Okay, so when theta is pi over 6, what point will we be at? Okay, when theta is pi over 6, that means that x will equal 2 cosine of pi over 6 squared. And what's that going to equal? That equals 3/2. And y is going to equal the sine of pi over 3, which is root 3 over 2. So that's what point we're looking at. 3/2, comma, root 3 over 2. Okay? Now, let's find the slope of the tangent line. So we need to find dy dx. Okay. dy dx equals dy d theta divided by dx d theta. Now, what's dy d theta? Well, that's very easy. Here's why. What's the derivative of that with respect to theta? It's going to be 2 cosine of 2 theta. What is dx d theta? Here's x right there. What's the derivative with respect to theta? Go ahead and work it out. Okay, and you should end up with negative 4 cosine theta times sine theta. Isn't that correct? Because you should get 4 cosine theta times negative sine theta. Okay? Now that can be simplified. Because that denominator actually equals negative 2 sine of 2 theta. Just using trig identity. Okay? 2 cosine theta sine theta is the same thing as sine of 2 theta. So our dy dx here is simply negative cotangent of 2 theta. That's dy dx. So when theta is pi over 6, that means that dy dx is going to equal negative cotangent of pi over 3, okay, which is going to be negative. Let's just think about this for a minute. Cosine of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2. So we're going to end up with negative 1 over root 3. Which some people would write negative root 3 over 3, but I don't think that's necessary. Okay, that's our slope. So can you write the equation of that line? I think you should be able to, right? You've got a point and you've got the slope. So then isn't the equation of the line y minus the y coordinate of our point equals the slope times x minus the x coordinate of our point? Let's just simplify that, okay? So we're going to get y equals, we'll have negative 1 over root 3 x, and then it'll be plus 3 over 2 root 3. Okay, that's the distributing there. And then we're going to add from the other side, we're going to add root 3 over 2 to both sides. And there's the equation of our line. Oh, by the way, it can be simplified even a little more. Do you notice this? 3 divided by the square root of 3 is, in fact, the square root of 3. Oops. So that's negative 1 over root 3 x plus root 3 over 2 plus root 3 over 2. What's root 3 over 2 plus root 3 over 2? It is square root of 3. So there's our tangent line. Okay? Can you find the normal line? The normal line is perpendicular to the tangent line. So the only thing you have to do is take the slope and insert its negative reciprocal. So that'll give us y equals negative root 3 over 2 sorry, not equals. Y minus root 3 over 2 equals square root of 3 times x minus 3 halves. Let's simplify that. It gives here root 3 times x minus 3 root 3 over 2 plus root 3 over 2. So that would be square root of 3 times x. What's that last part going to simplify to? Won't it be negative 2 root 3 over 2? But then those 2's will cancel, won't they? So we just get minus root 3. And that's our normal line. Okay, so that's not too bad. Okay, next type of question. How would you find an area enclosed by a polar graph like is pictured here? There's a cardioid. Okay, and shaded blue is the area inside the cardioid from theta equals pi over 6 to theta equals pi over 3. Okay, and that cardioid, by the way, what's the equation of that? Let's write that down. The equation is r equals, that particular one is 1 plus cosine theta. Okay, so how do you find that area? I'm going to show you the formula right now. The area equals the integral of r squared with respect to theta from alpha to beta, where alpha is the beginning angle and beta is the ending angle. And then you cut that in half, and that'll give you the area. So for us, that's going to be 1/2 integral from pi over 6 to pi over 3, 1 plus cosine theta squared d theta. Okay, so that's a very easy integral. Let's see, what is that? That's 1 plus 2 cosine theta plus cosine theta squared. Okay, now you should have learned how to do those in calculus too. Of course, 1 is easy to integrate, 2 cosine theta is also easy to integrate. Okay, you should have learned in Calc 2 how to integrate cosine squared. Okay, let's write down what we're going to get. You get theta plus 2 sine theta. So those two should be very easy. Okay, but you should be able to do the next one too. That's going to be 1/4 sine of 2 theta. Okay. And then we go from pi over 6 to pi over 3. So go ahead and plug those numbers in and see what you get. Okay? Pause the video if you need to. I would like you to work that out. Plug those numbers in and see what you get. Here's what you should have. 1/8 times pi plus 4√3 minus 4. That should be your answer. Okay, and that's how much area is shaded in the picture. if you want to find the area between two polar curves, like this next picture, okay, then you just do the difference. So what I mean is this. Let's call this outside one R1. And let's call the inside one R2. Okay, and let's call this angle alpha, this angle beta. Then that shaded area would just be 1/2 integral from alpha to beta, and you would just do R1 squared minus R2 squared d theta. Because then what you're doing is you're finding the area inside the blue circle, and you're subtracting from that the area that's also inside the red cardioid. And that will leave you with the area that's shaded. Okay, and finally the last thing I want to show you is arc length. For arc length, okay, we integrate the square root of r prime squared plus r squared. Okay. This will work as long as r prime is a continuous function. So, on that picture to the left, I have the same circle that we started with at the beginning of the lecture. R equals 2 cosine theta. I just want to point out to you really quickly that the radius of that circle is 1. Okay, so let's find the circumference. Well, I hope you know from high school geometry what the circumference should be, but let's calculate it ourselves here. Okay, so we're going to integrate. What are our two angles? Notice that circle is only in quadrants 4 and 1, so we're going to integrate from negative pi over 2 to positive pi over 2. We integrate the square root of r prime squared. What's r prime? R prime is negative, no, not negative, sorry. R prime is, yeah, that's right, negative, sorry, negative 2 sine theta. Okay, so we're going to square that, and then plus, still under the square root, 2 cosine theta squared. This is going to be such an easy integral. What's that come out to here? Let's simplify that. So that's 4 sine squared plus 4 cosine squared, right? All right, inside of a square root. Isn't that just the square root of 4? Because sine squared plus cosine squared equals 1. So that's just the square root of 4. And what is the square root of 4? It's 2, right? So we're just integrating 2. See, I told you it would be easy. So we get 2 theta from negative pi over 2 to pi over 2. That's going to equal theta minus negative, I mean not theta, sorry, pi minus negative pi. And that's going to give us 2 pi. That's the circumference. Is that what the circumference should be? Well, let me remind you that the circumference of a circle is 2 pi times the radius. So that circumference should be 2 pi. So that's good, we're correct. Okay, that's the end of this lecture. Have a good day.